Now let's look at part 2. Part 2 is the evaluation theorem. So it means we're going to use part 2 to evaluate. Evaluate what? Evaluate the area under the curve. So if f is continuous over the interval and f of x is any antiderivative function of f of x, then the integral from a to b f of x, this is finding the area under the curve between a and b, will be equal to the output of the antiderivative function where the input is b minus f of a. Okay, so it means in order to this type of problem, you will have to find what is the antiderivative of the function f first, and then you put in the value b and a. So we're gonna have, let's take a look at this example. So I have the function is t squared plus 4. I need to antiderivative t squared plus 4. And what is the antiderivative of that? So recall that the integral of a constant is constant times the variable. And the integral of the x to the power n dx will be x to the power n plus 1 over n plus 1. Okay, so you have t squared plus 4. It means the power will increase by 1. And then you divide the power that you just increases. And then integral of the constant is constant term variable. And then we take it from -2 to 2. And the fundamental theorem part 2 is telling you that you will put in the upper bound to the antiderivative function and take that minus the lower bound. So how would we put in this? So we're gonna put in 2 into the t. So I'm gonna have putting 2 into the t. So we have 2 to the power 3 over 3 plus 4 times 2. Okay, this is my FB. And then we need to minus FA. What is FA? FA, we're going to put in -2 into the t. So we have -2q over 3 plus 4 times -2. Okay, so this is my FB minus FA. And we're going to have 8 over 3 plus 8 minus -8 over 3 minus 8. And then be careful because there's a lot of common mistake from here because there's a subtraction right there. So we're going to have to distribute the negative to the number. So we have 8 over 3 plus 8 over 3 plus 8 again. So it's going to be 16 over 3 plus 16. And that will give you, if you put that in the calculator, it will give you 64 over 3. Okay, so that's how you find fundamental theorem part 2 and use that to determine the area under the curve. So it means the area under this curve and bounded between -2 and 2 will have the result is 64 over 3. Okay, and then let's try another one. So I have integral from 4 to 8, and we want to evaluate this integral. First, we're going to find out what is the antiderivative of this. So the antiderivative is 3 is a coefficient, so stay the same. X to the power 2, power will increase by 1, so x3 over 3. Plus 4 is a coefficient, stay the same, so x to the power 2 over 2. And then minus constant times x. This should be an x, okay? This should be an x. And then we're gonna have to put in the bound. The bound is 4 and 8. So I would suggest you simplify first before you put in the bound. So I'm gonna simplify, and that will give you x cubed plus 2x squared minus x. And then we take that from 4 and 8. And we're gonna do FB minus FA. So we putting 8 cubed plus 2 times 8 squared minus 8. and then minus 4 cubed per 2 times 4 squared minus 4. And then if you have a calculator, we're going to use calculator to evaluate that. So we have 8 to the power 3 per 2 times 8 squared minus 8. And then minus 4 to the power 3 per 2 times 4 squared. And then minus 4. We have 540. Let's try this one. We have e to the power x plus 1. Antiderivative of e to the power x is e to the power x. Antiderivative of 1 is constant times x. So it's going to be 1 times x. And we take it from 1, 4 to 4. Okay? And then we substitute 4 into the function. So e to the power 4 plus 4. That is FB. And then minus e to the power 1, 4 plus 1 over 4. Okay, and we're gonna have, if you want to approximate, you can approximate this, e to the power 4 plus 4, and then minus e to the power 1, 4 plus 1, 4. And that will be 57.06.